This episode is supported by MonsterJoysticks.com. Level up your Raspberry Pi with our all-in-one arcade kit using genuine Sanwa arcade parts.
People told us they loved NeXT and that it was 3, 4, 5 years ahead of anything else they'd ever seen in the industry. And they loved the fact that we built it on top of Unix, because together this gave them the multitasking that they really wanted. It gave them the transparent networking that they needed. It gave them the object-oriented development environment so that they could build applications in a third of the time. It gave them multimedia, and they told us they loved how they could take computer illiterates and they could be using the system within a very short amount of time. One of the neatest things to me is that we have been recognized as having the most automated factory in the computer business. Every single one of the products here today at Davies was built in that automated factory. And after we finish building the boards, the next station goes together with only 7 screws.
Hello Cave Dwellers and welcome back to the cave as we continue our tour of this NeXT Station Turbo Color, the slab of which came out of that state-of-the-art factory described there by Steve Jobs. Just how many came out of that factory? Well, we'll find out a little bit later. But first of all, we need to take a tour of the software because I have the cables all set up and the capture system is now working, so I can take you through it. I'll be giving you my impressions of the NeXT operating system, and we also have an experienced developer, Michael, joining us, who'll take us through NeXT Developer, which is included as part of this package here. And with the tour concluded, we'll find out about the legacy that NeXT Computers left on the IT industry as a whole. So let's find out what happened next to NeXT. Next. So the hardware which we were introduced to in part 1 was complemented by the NeXT operating system, created by a team led by Avi Tavanyan, the VP for software at NeXT. And this is NeXT booting up, so let's take a poke around. The OS is a Unix type operating system based on the Mac kernel. That's Mac M-A-C-H, or Mark if you're American, and not Mac as in Apple, which had input from Avi while at Carnegie Mellon University as an engineer there. It also incorporates some BSD Unix source code. Now some of you will start to notice familiar elements in the OS as I log in and start to poke around with the system, especially if you use an Apple computer. The spinning activity ball, for example, will be an extremely familiar sight. But the basic elements of an operating system are all here: our windows, icons, menus and pointer. The window in the centre of the screen here is a file viewer, offering a graphical representation of the file system on the hard disk. The directory tree should be familiar to any users of Unix or Unix derivatives, with folder names such as bin, dev, etc, lib and so on in the root. Being Unix based, it's a multi-user OS, with our home folders stored in the users folder here. And the icon path near the top of the window shows our current selected location or file. The top part of the window is called the shelf, and you can drag folders up there as a kind of shortcut system. A quick change of view reveals columns for permissions and groups, as well as the file or folder owner. Pretty standard stuff under the hood then, and a terminal can also be opened to explore further from the command line, where all your favourite Unix commands can be used, or at least those from 1992. On the left here we have menu lists, which you might typically expect to find lining the top of an application window or the screen in other operating systems. The menu list changes according to the application which has focus, and it can be expanded and torn off like so to suit your workspace. You can tear off as many menus as you like and quickly organise or clutter your screen. On the right side of the screen we have what's called the dock, another familiar name to Apple users. Regularly used applications can be pinned and accessed from the dock, as well as the recycle bin located down at the bottom of the dock there. Exploring the file system reveals some included applications, all of which you'll notice end with the .app file name. You can double-click these to run the application, and just like in Mac OS X, they can be browsed like a folder to see the files within them. An application and all of its files in a neat package, very user-friendly. And here's the Webster Dictionary and Thesaurus application container as an example with its files all neatly stored within. And what about those applications? What do we have bundled in with the system? Well, all the usual suspects are here really. A text editor is essential, if unexciting, but it does give our first taste of the shared and unified panels which applications have access to, such as the font panel here, another one to tick off your Apple bingo cards. And it also has a colour panel for colour selection in a variety of forms, from the colour wheel to Pantone matched colours. Pantone a clear nod to Jobs aiming for sales from the illustration and print market with this machine, as he alluded to in earlier presentations. Some more fun applications include a game of chess. Now, my chess playing abilities really offer no indication as to the intelligence of this game, but it was fun, and I predictably lost. How about a Breakout clone then? How about two in fact at the same time? Breakout, the arcade game of course co-designed by Steve Wozniak for Atari, with Steve Jobs acknowledged in assisting him in 1976. Boink Out, a bit of fun, but we're not really flexing the machine's muscles here. Something a bit more demanding then is Fractal Rendering, a Mandelbrot app. A common application really in most computers at the time, especially in schools and universities. It all feels very slick compared to contemporary operating systems, with a uniform and consistent design language across all applications and a beautifully high-resolution colour display. Now, I was using Windows 3.1 at this time, and seeing this really would have been an eye-opener for me. The quality of the display comes into its own, with some desktop publishing using FrameMaker here, and the assurance offered by the PostScript display that what we're seeing is how it will come out of the printer would have been a powerful combination at the time. But it is still a real stretch to consider it being worth the cost of the machine and to dismiss cheaper alternatives just for desktop publishing. Steve Jobs, of course, extolled the online virtues of the NeXT machines and their ability to play nice together on a network. I had no problem connecting it to my local network with a gateway to the outside world. Email, of course, was established long before the NeXT, and an email client is present here, with one solitary email waiting for us, from none other than Steve Jobs himself. And then there's the World Wide Web. The web is a monumental chapter for NeXT computers and really does cement its name in the history books, having been created by Sir Tim Berners-Lee using his NeXT Cube. Shared documents using hyperlinks to reference each other, stored in accessible network locations, could help solve a real problem of losing information at CERN, where he worked at the time. The first website was hosted on Sir Tim's NeXT machine, and the first web browser, World Wide Web, ran on the NeXT, but was later renamed to Nexus to avoid confusion. And here is a version of that web browser, displaying that very first web page on a NeXT computer. This is where the web began. Would this have been invented without the NeXT? Well, the likelihood is yes, as a problem existed in sharing data which needed to be solved. It just so happens that the NeXT was at CERN, and it may well have been there because of its merits in object-based rapid programming. To explain a little more about that side of things, I've invited an experienced NeXT user to show us the basics. Let's take a look.
Thanks, Neil. I'm Michael, and software archaeology and preservation is a passion of mine. While I didn't use NeXT in its heyday, I've done more than a little poking under the hood as part of other projects. As a software developer, though, if I had to use one word to sum up NeXT, it would be modern. Now, that may seem like an oxymoron, but even now, NeXT is surprisingly close to what modern developers take for granted. Just as the original Macintosh brought graphical user interfaces to the masses, NeXT can be seen as the herald of modern software development. It could be best described as a collection of highly polished ideas. For example, object-oriented programming as a concept can be dated back to the late 50s in the Lisp programming language at the MIT Artificial Intelligence Labs. The primary programming language, Objective-C, was heavily influenced by Smalltalk, which was created by Xerox PARC for use with their Alta, which incidentally was the same machine that Steve Jobs took inspiration for the Macintosh user interface. After installing the NeXT Developer CD, the applications folder is populated with two applications that primarily make up the NeXT development environment. And that is Project Builder, which is an integrated development environment, and Interface Builder, which is used to create user interfaces and interconnect them, which we will show in a moment. So first, let's open Project Builder. In Project Builder, and for those who have worked on Mac OS X, this should look very familiar. Files are divided into classes, which are made up of Objective-C code, like this. You have header files, other resources, and interfaces, which are components that build up the user interface of a given application, which can be made with drag and drop. I will show this off more a little later. Another large advantage is that NeXT supported multiple architectures and did so in a native and rather seamless sort of way, as seen here, where I can simply choose to build this graph application for original NeXT hardware, Intel platforms, PA RISC, and Spark. In contrast, while Microsoft and other vendors experimented with multi-platforms, such as Windows NT on RISC-based architectures, oftentimes specialized tools were required and specialized hardware from which to build to. The underlying technology for this, known as fat binaries, persisted in the core of NeXT well into Mac OS X, and most users these days would be familiar with the concept as Apple's universal binaries used when they transitioned from PowerPC to the Intel architecture. An important concept to show in NeXT is object-oriented components and how they interact with each other. Here I've created a new project in Project Builder to demo this. So let's open Interface Builder and let us grab a vertical scroll bar like this. We'll make it nice and big. We'll grab a title, and what I'm going to do is create what's known as a connection like this. And this allows one object to send another object a message. It can be an error component, or it could take, or it could be an Objective-C class. But I can take a target, I can tell it take an action, in this case take float value, and send it to that text field to display information. So that is one thing we're going to do. Then, because Neil showed this off earlier in his video, I'm going to take a text area, a scroll area I should say, and then I'm going to grab a font menu and drop it into my menu bar like so. And this is going to form the basis of our object-oriented program. So I'm going to close Interface Builder. We're going to build this, and once it compiles, we're going to run it. So here's our basic application, and as you can see, I did not have to write a single line of code to make this work. I just drag the bar and the text field right here updates. Now, this is a standard text window. Earlier, I grabbed the font component, and now I have all the built-in functionality of NeXT's font UI. I can change the font, I can make it bigger or smaller. This was all done in 30 seconds without writing a single line of code. Other operating systems like Windows or Mac OS of the time would require a fair bit of boilerplate to reach a level similar to this in terms of functionality. So to summarize, in 1989, when NeXT was released and continuing well into the Windows era, most programs were coded using procedural programming methods versus the object-oriented ones I demonstrated here. Competitors such as Microsoft took note of the end-user experience offered by NeXT, such as the ability to drag and drop arbitrary data, and created their own versions of this. Microsoft, for instance, created the Component Object Model, or COM, which was essentially a bolt-on object-oriented layer for the Windows API, and then later used to create object linking and embedding, which was used with Office and underpins modern data exchange in Windows today, now using the then new C++ programming language. I hope that this short demonstration of the development environment offered by NeXT does show that it did in fact live up to the marketing hype, and it did set the path of industry. Would these type of things have existed without NeXT? Possibly, but not in the sense that we know them today.
If you look at what other people are doing these days, is they have realized that object orientation in your development environment is key. It could be said to be the next major step in terms of how people develop software.
A powerful set of tools indeed then, tools which were put head to head in this promotional video from NeXT with a Sun workstation, in which the NeXT developer of course creates his application far more quickly and with more features than the Sun developer. Seeing the stuffy looking Sun developer being bested by the cool NeXT developer, you can perhaps see where the I'm a Mac, I'm a PC marketing campaign came from in later years from Apple.
The Sun implementation lacked many important features. It could not display or print the scanned manual pages, nor did the trouble log recall button ever advance beyond the prototype stage. And while the NeXT implementation allowed access to all the system type fonts, including their various styles and sizes, the Sun implementation only provided a few type fonts and styles that were pre-selected and hard-coded by the programmer. In fact, many of the features in the Sun implementation were hard-coded.
And that's at the heart of NeXT, to create a joined-up experience across applications and the operating system. For example, if I return to that Steve Jobs email, I can drag and drop the image directly off of the email and into a FrameMaker file, and it understands perfectly what to do with it and presents it in the document. Likewise, I can then drag a text file, for example, into the same FrameMaker document and our text appears. And that was a level of integration built from the ground up that we just didn't see in other operating systems of the time. Over these last two episodes, we've now got a feel for the hardware and the software bundled with the machine, as well as the target market. So what was happening at that high-tech factory with a capacity to produce 150,000 computers a month? Well, let me tell you, the total number of NeXT computers produced is reported at 50,000 across all models and the life of the company. 50,000, a third of a month's production in the factory. Second generation machines, such as this model, could do nothing to save NeXT, and plans to turn to a new RISC-based architecture were dropped. So where did they turn next? Well, they turned their focus away from hardware and towards software only. The NeXT operating system was ported to 486 PCs and later to SPARC and PA RISC-based platforms.
And OpenStep was a realization that what our real jewel was our object layer, not our complete stack of hardware and operating systems and object layers. So if we could just break that object layer out and run it on popular operating systems, a lot more people would want to buy it. We've been at that work for the last few years, and it will be shipping in the first half of next year. And OpenStep has a lot of partners: Hewlett-Packard, Sun, Digital, each of them doing OpenStep work. Sun has announced their schedules. They will also be shipping around the end of this year to early next year. Others will be announcing their schedules shortly.
The workstation will be rearranged. Hewlett-Packard is now made the same. BA RISC is what we made. Working fast will be the norm. New applications can now be born. Cause the hottest desktop in the world, a brand new era we've unfurled.
Who knew PA RISC was so funky? NeXT gained customers in high places such as the CIA and large banks. The OS then proving to be adaptable, although it wasn't troubling competitors' OSs with its sales numbers. In 1993, NeXT stopped producing hardware entirely and renamed the company to NeXT Software Incorporated. NeXTSTEP was now known as OpenStep, reflecting on its ability to run across multiple architectures, as well as WebObjects, a platform for building large-scale dynamic web applications. It was beginning to look like a very different company. But then, in 1997, following lengthy acquisition proceedings, this happened.
You want to put the Mac OS System 7 and the modern OS on the same system core, and therefore get the best of both worlds. The NeXT technology came out as the clear winner by 50% or so in terms of all the things that we felt were important. Along with the application, we also got this guy named Steve Jobs.
Apple, in dire need of a replacement operating system for their aging classic Mac OS, chose NeXT software to provide the modern foundation for OS X. And so, NeXTSTEP, now OpenStep, would be ported over the next 5 years to the PowerPC architecture, just as was intended for the third generation of NeXT computers, but now as an Apple product under the codename of Rhapsody, with Steve Jobs as a consultant, and then an interim CEO, and finally in the year 2000 the permanent CEO of Apple. And the following demo at the Expo further served to highlight their need for this.
This is the ultimate in integration of hardware, software, of technology, of industrial design. It is perhaps the world's first flat panel television set, and with a click of a mouse you can get your CNN News. And we hope the click of the... I didn't do my sacrifice to the demo gods earlier.
The familiar spinning ball, the dock, the Finder browser view, and even chess made its way into Apple's operating systems, at first on the new server edition of Mac OS X, and then Mac OS X for the desktop and laptop computers, and the Aqua GUI was layered on top. And of course the foundations of OpenStep, and now OS X, were built to be adaptable to new platforms, so when Apple made the switch to Intel processors, OS X could be adapted accordingly. While I can't claim this was a groundbreaking or revolutionary machine in terms of raw power, or that it achieved the dreams of Steve Jobs in his earlier presentations, it did make some big waves in the longer term, especially for a smaller company. It prompted competitors to prioritize object-oriented programming and graphical user interfaces, with Apple attempting to build a similar operating system in their Taligent project before acquiring NeXT, and Microsoft in their Cairo project in 1991. Elements of which made their way into Windows 95 and beyond. WebObjects may have failed to become popular in the longer term, with the exception of iTunes, but it was the first example of a web application service that enabled dynamic page generation based on user interactions, so no small legacy there either. Oh, and there's one other bit of software we owe to NeXT. The graphic engine for Doom was developed on NeXT hardware, so the NeXTSTEP version of Doom existed before MS-DOS. So maybe it was worth it all after all. And therein ends our tour of the NeXTstation Turbo Color today. I hope you enjoyed finding out more about it, as well as the surrounding history, and I'd love to hear your thoughts on the legacy that it left. I'd like to say a very special thank you to Neil at Oxford University, who very kindly loaned us this machine, and without his generosity we wouldn't have been able to find out more about it over these last couple of episodes, so thank you very much to Neil. Now, in episode 1 I mentioned that I wanted to show you NeXTSTEP on a 486 PC. I still fully intend to do that, we just didn't have time to squeeze it into today's episode, so stick around and I'll dig out the 486 and we'll see how we get on with that and how it compares to the black hardware over here. As always, thank you for watching and take care.
The power shifted in your door. By any measure, brother, you'll get more. Next steps, we've hit the mark. We're leaving other systems in the dark.
If you enjoyed this episode, please consider supporting the channel using the links in the description, visit monsterjoysticks.com/RMC, or simply subscribe and come back for more soon.